In this video, we will work on the derivative of inverse functions, but we only cover the inverse trig functions and their derivative. Okay, so then now let us look at kind of like how we define the inverse function now. Okay, so it said that right here, if f is one-to-one function with domain A and range B, then its inverse, f inverse, is the function with domain B and range A defined by f inverse of x equal to y, or y that f of y equal to x. Okay. Therefore, f inverse is a rule that reverses the action of f, right, from output back to the input then. Okay. Okay. So here is the idea to understand a little bit more about the inverse functions. Okay. So in this case, for example, if we have a functions, then the input is 3, and then the output is 5. Okay. And then this is the f function right here. Then we write down f of 3 equal to 5. Okay. If the function is one-to-one, what we can do here is we can actually trace it back from the output back to the input. Okay. So in this case, we could write it as f inverse of 5 equal to 3 then. Okay. So this is, again, the idea about the inverse functions. Okay. So notice f inverse, okay, of x is not equal to 1 over f of x. It's not a reciprocal, okay? And if a function has inverse, it is said to be invertible then. Okay. Then now, let us look at kind of like the map diagram that we have here, okay? Okay, so this is how we're mapping the input and the output. Now, if we have A, okay, is the input of f, okay, then we go through from A to B, right? We go through the f functions. Then in this case, we will have the output, which is f of x then. Okay. Similarly, if y is the input of the inverse functions, okay, so in this case, y is the output, right, of f. But now we would like to, using the output, go through the f inverse, then we will go back to the x, which is the input then, okay? So therefore, in this case, to the inverse functions, the y become the input, and then x become the output then, okay? So therefore, in this case, okay, if A is the domain of f, and B is the range of y, of f, okay? Then to these inverse functions, then B will be the domain of the inverse, and A will be the range of the inverse function then. Okay, so that's why you will see that here. The f functions has the domain A and range B. To the inverse, you will have the domain B and range A then. Okay, so this is kind of like the idea. Okay, okay, then now let's go back to the inverse sine, cosine, and tangent function now. Okay, because in order to get an inverse function, it must be a one-to-one functions. Okay, and now you will see that to the sine functions, it actually is not one-to-one because it's actually failed the horizontal test, right? Okay, so therefore, in this case, what we need to do is we need to restrict the domain to make it one-to-one. Okay? And then what if I restrict it between negative pi over 2 to pi over 2? Okay. In this case, you will see that what happened is we have a one-to-one function now. Okay. In this case. Okay. Then, of course, if I want to sketch the inverse functions, okay, basically, in this case right here, you have to know, okay. Okay, so maybe let us try to work it out to the sine of x functions, okay. To these functions, the point that we have, okay, it will be negative pi over 2 and negative 1, okay. And then negative power 4, negative power 4 is actually, it will be negative 2 over 2. Okay. And then of course, we have the point 0, 0. And then we also have pi over 4 is √2 over 2. And then we also have pi over 2 is actually 1, right? So this is actually the point that we get it from the sine functions, okay? And now the inverse functions. Okay. Remember, how do we actually work with the inverse function? We swap the input and the output, okay? So in this case, to the inverse functions, I will have negative 1, negative pi over 2, negative 2 over 2, negative pi over 4, 0, 0, and then √2 over 2, and then pi over 4. And then I have 1 pi over 2 then, okay? So then now, you will see that in this case right here, we will have, again, negative 1, negative pi over 2, and negative √2 over 2, okay? And then we will have negative pi over 4, right? And then 0, 0, and then √2 over 2, and then I will have this is pi over 4. Okay. And then I have 1 and pi over 2. So therefore, in this case, this is my inverse functions, okay? So in this case, okay, then now let's talk about the domain and range now. You see, the domain of the sine functions, it will be between negative pi over 2 to pi over 2. And then the range is between negative 1 and 1. Okay. However, let's look at the domain of the inverse functions is negative 1 to 1. And then the range is from negative pi over 2 to pi over 2. Okay. Do you see that now? Basically, we swap the input and the output. Okay. When we work with the inverse functions. Okay. Then tangent is the same. What we would like to do is we would like to restrict the domain between negative pi over 2 to pi over 2. Okay, so then we will have a one-to-one functions. Then now, when we work with the inverse, right? Then this is the inverse tangents. So to this inverse tangent, the domain will be between negative infinity to infinity, and the range is between negative pi over 2 to pi over 2. Okay. Okay, now similarly to the cosine functions, okay. The cosine function is a little bit different than the sine and tangent. Okay. In this case, so to the cosine function, if you keep, that means restricted between negative pi over 2 to pi over 2, then what happened? The function is not one-to-one. Okay. So therefore, to the cosine function, we would like to restrict the domain between 0 and pi now. Okay. So then we will have a one-to-one functions. Okay. Then again, when we work with the inverse, so therefore again, you see to this point right here, it will be 0, 1. This point right here is pi over 2, 0. And then this point right here, it will be pi and -1. Okay. So when we change it back, then we will have the point 1, 0, 0 pi over 2, and then -1 pi. Okay. Okay. Then the functions sine inverse, tangent inverse, cosine inverse, sometimes we call them arcsine, arctangent, arccosine. Okay. Okay. And now let's see how we evaluate, okay, get the exact value for the sine inverse of root 2 over 2. Okay. Now, when you look at this, okay, what I would like to consider is I would like to consider that, okay. So again, when I look at the sine inverse of root 2 over 2, okay, it is equal to the answer, maybe I call this x, okay. So in this case, what I would like to consider that is I would like to know sine of what angle is equal to root 2 over 2. Okay. Now remember when we work with the inverse functions, okay, the angle that we are going to be straight, okay, look it back to the sine inverse, okay. You see that the output that I have must be in between -pi over 2 to pi over 2, okay. So meaning this x right here, it must be in between -pi over 2 to pi over 2. Okay, this is kind of like the result. Okay, so therefore, in this case, okay, again, if we look at this, -pi over 2 to pi over 2 is okay, it will be in quadrant 1 or in quadrant 4 then. Okay. So that means in this case, the angle that I have, because this is positive, so the x must be in quadrant 1. Okay. So then if we look it back, the sine of pi over 4 is equal to root 2 over 2. Okay. So therefore, in this case, the x value, it must be pi over 4. Okay. Or you could check it out that here, sine of x, the angle, then my output is root 2 over 2. Okay, so we check it out. Then we trace it back to the angle. Okay. And my answer is pi over 4. Then similarly to this one, if I'm looking for cosine inverse of root 3 over 2, then what I would like to think of this problem here is, okay, now I could look at the output is root 3 over 2, and then we trace it back to the input, the angle, which is pi over 6 then. Okay, well, that's it. So this is kind of like the idea. Okay. Okay. And now let us look at the next example now. Okay. So to this one, what I would like to consider if I want to take the limit, okay, then let us look at the graph of the sine inverse of x, okay. 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 Then now, as x approach -1, need to fix my graph, okay? Okay, so now, as x approach -1 from the left, okay, then my output is actually get to -2, okay? Or you could consider that, again, in this case, what we could consider is, I would like to have psi of x is equal to -1. Then what is this angle equal to? Then we could look at the psi functions. In this case right here, then we could check it out that between -2 to pi/2, then this one is 1 and -1. And okay. So this is the psi function right here, okay? Then in this case, again, if I'm looking for the angle that give me the output is -1, then of course, in this case, my answer will be -2, okay? Remember this function right here is the sine inverse of x then, okay? And now, let us look at our next example then. Okay, so now, in this case, what I would like to do is, I would like to find the limit x approach infinity of arc cosine 1 plus x squared over 1 plus 2x squared, okay? So in this case, again, this is kind of like a composite function, right? So what we could do is we could evaluate the arc cosine of the limit x approach infinity of 1 plus x squared over 1 plus 2x squared. Okay. Okay. So to this one, remember, as x go to infinity, if we have a rational functions, how we take care of this? We could multiply top and bottom by the degree, right, of the denominator. We look at the highest degree. So I will multiply top and bottom by 1 over x squared. Okay. And now I will have arc cosine of limit x approach infinity. And then I have 1 over x squared plus 1 over 1 over x squared plus 2. Then, of course, we know that this go to 0, this go to 0. So I will have arc cosine of 1/2. Okay. So then arc cosine of 1/2 is pi/3. Okay. So my answer will be pi/3 then. Okay. Okay. And now let us get to the talk. How do we actually take the derivative of the inverse trig function now? Okay. Okay, so maybe let us try to look at the derivative first. Okay. Now the derivative of sine inverse of x is equal to 1 over square root of 1 minus x squared. The derivative of cosine inverse of x is equal to negative 1 over square root of 1 minus x squared. Okay. And then you will see that it's kind of like the derivative of sine inverse and cosine inverse is really similar. The difference is when we take the derivative of cosine inverse, we carry the negative sign. Okay. The derivative of tangent inverse is equal to 1 over 1 plus x squared. And the derivative of cotangent inverse is negative 1 over 1 plus x squared. Okay. And again, the derivative of tangent inverse and cotangent inverse is kind of like a pair. Again, when we take the derivative of cotangent inverse, we carry a negative sign. Okay. And then the last pair that we would like to look at is the cosecant inverse and secant inverse then. So the derivative of cosecant inverse is negative 1 over x times square root of x squared minus 1. And the derivative of secant inverse of x is equal to 1 over x times square root of x squared minus 1. Okay, now one thing that you should notice, when we take the derivative of the inverse trig, the answer that we have is only related to this xy here. It's nothing related to the trig functions. Okay. Why does that happen, huh? Okay, so let's see. How do we actually prove that then? So in order to prove the derivative of sine inverse of x equal to 1 over square root of 1 minus x squared, we need to know some identities, okay, before we actually work it out this proving stuff, okay, proving trig functions, inverse of trig functions. We need to remember that the 3 identities, okay, cosine square x plus sine square x equal to 1. 1 plus tangent square x is equal to secant square x. 1 plus cotangent square x equal to cosecant square x. Okay, those are the things that we need to remember, okay, in order to work it out the following problems then. Okay, then let's see, how do we actually start the problem? Okay, so to this problem, what I would like to do, the first step, I would like to let y equal to the sine inverse of x. Okay. Then now, second, I'm going to rewrite this into the form that sine of y is equal to x. Okay. This is basically using the property. Okay. Okay. Then now, number 3, we are going to work with implicit differentiation now. So we are going to take the derivative with respect to x to both sides of the equations. And now we find out that the derivative of sine of y, it will be cosine of y prime equal to 1. Then now, just like what we do, we would like to solve for y prime, right? So I'm going to have y prime equal to 1 over cosine of y. Okay. Okay. Then now, what I need to do is I need to find, okay, so then this will be my step number 6 now. I would like to find cosine of y equal to what then? Okay. Now, how do we do this? Then, one thing that we know is we know that sine of y equal to x, and we know that cosine square y plus sine square y is equal to 1. Okay. these identities. Then now, once we know these two information, then we will be able to do the problem now. Okay. Since cosine square y plus sine square y equal to 1, then we know that cosine square y plus, okay, now when now sine of y is equal to x, so I will have x squared equal to 1. Then of course, I would like to solve for cosine of y then. Okay. Okay. Then now, once we have this, okay, then we could go back to the problem. So now I will have y prime is equal to 1 over cosine of y is a square root of 1 minus x squared. Okay. So now we will say that the derivative of, again, y is the sine inverse of x is equal to 1 over square root of 1 minus x squared. Okay. Okay. So now it is your turn. Okay. Now go ahead and try to see if you could work on the next proof then. Okay. So try to see if you could follow these 7 steps, okay, to finish the problem. I would like to let y equal to the cosecant inverse of x. And then I will have cosecant of y is equal to x. Okay. And now we take the derivative with respect to x to both sides of the equations. Okay. Then, I don't know if you remember the derivative. The derivative of cosine inverse, it will be, I'm sorry, cosecant of y, right? It's actually, it will be negative cosecant y, cotangent y, y prime equal to 1. Okay. And again, the next step is we solve for y prime. So I have 1 over negative cosecant y, cotangent y. Okay. And again, we know that the cosecant of y equal to x, and 1 plus cotangent of y equal to, or square, cosecant square y. Okay. And now, based on this here, then I have 1 plus cotangent square y is equal to x squared. Then cotangent square y is x squared minus 1. And then cotangent of y is the square root of x squared minus 1 then. Then now, this is x. This is the square root of x squared minus 1. So I will have negative 1 over x times square root of x squared minus 1. Okay. So therefore, in this case, we could say that here is the derivative of cosecant inverse of x is equal to -1 over x times square root of x squared minus 1. Okay. Yeah. So now we would like to go to work on the derivative now. Okay. Okay. So now if I want to find the y prime, okay, then to find a, first of all, I need to rewrite this into the tangent inverse of x raised to the power of 1/2. Okay. And then let's review. If I take the derivative of u to the 1/2, okay, then what do I have? I will have 1/2 u to the -1/2, and then u prime, right? Chain rule. So then in this case, we could consider that this is my u right here. Okay, then let's see. So I will have y prime is equal to 1/2 tangent inverse of x raised to the power of -1/2, and then we take the derivative of the tangent inverse of x then. Okay. So I will have 1 over 2 times square root of tangent inverse of x. Okay. And the derivative of tangent inverse of x is 1 over 1 plus x squared. Okay, so maybe let us try to combine everything together. So I will have 1 over 2 times 1 plus x squared times square root of tangent inverse of x then. Okay. So then this is my y prime. Okay. And now let's check it out the next example then. Okay. So to this example, again, I have composite functions that we could consider that this is the u that we have here. Okay. Then first of all, if I have cosine inverse of x, if I take the derivative of this, it is a -1 over square root of 1 minus x squared. Okay. Then if I take the derivative of cosine inverse of u, then it will be 1 over square root of 1 minus u squared, right? We replace x with u, but since u is dependent on x, so I need to take the derivative of u then. Okay. So then now to this one, I will have y prime is equal to a -1 over square root of 1 minus sine inverse of t to the square. And I take the derivative of the sine inverse of t. Then now, what I need to do is I just need to show that the sine inverse of t, the derivative of this is 1 over square root of 1 minus t squared. Okay. So again, if I want to combine them together, it will be 1 over, okay? The whole thing is under, okay, again, remember square root of x times square root of y equal to square root of x times y. Okay? Then I could have I will have 1 over square root of 1 minus t squared times 1 minus sine inverse of t to the square then. Okay. Okay. Then to this problem, how do we actually work it out of this one? Okay. So again, first of all, I think I will work on this one first. So I will rewrite this into x times sine inverse of x plus 1 minus x squared raised to the power of 1/2. Okay. Okay. Then notice we have two terms. The first term, we need to use a product rule because a product. And then the second one here, probably we need to use a chain rule then, right? Okay, then let's see. So I will have y prime is equal to the derivative of x times sine inverse of x plus x times the derivative of the sine inverse of x. Okay. And we would like to add, okay, this one right here, it will be 1/2. 1 minus x squared raised to the power negative 1/2. And we need to take the derivative of 1 minus x squared, okay, which is the inner function here. And now I will have the derivative of x is 1. So I have sine inverse of x plus x times the derivative of sine inverse of x is 1 over square root of 1 minus x squared. And then we would like to add this one. Okay, let me use different color then. This is 1 over 2 times square root of 1 minus x squared and multiply to negative 2x. Okay. Sine inverse of x plus x over square root of 1 minus x squared. Okay, 2 and 2 cancel. Minus x over square root of 1 minus x squared. And this one and this one cancel. I will have sine inverse of x. Okay, so then this is my y prime. Okay, so that's it for this video now. Okay, thank you.